other things can be delivered mucosally, it comes with certain precautions, and safety measures, as well as improved stability, measurement to improve stability. So among those available measures to control the mucosal pathogens, today's lecture will be basically the probiotic-based therapy, and I will give you a few examples of how probiotic can be used as a vector-based vaccine to achieve a targeted benefit, and I will show how the next generation probiotics can be created for betterment. So as I said, the mucosal delivery, since these are the key factors needs to be addressed, whatever you want to introduce to mucosally, either as a vaccines or as a therapeutics. So why probiotic? As you know, this is very common to all, that probiotic has their all beneficial effects, including they are considered as generally regarded as safe for human consumption, which again, there is no issue with FDA or any other regulatory bodies. So it's always, whether it's FMG or it's probiotic-based capsules, we all are safe. So, and another advantage, the particular probiotic, which are lactic acid producing bacteria, in particular Lactococcus lactis, that we are going to show how we are going to bioengineer, is very low GC content. That means that any protein of any heterologous protein, you can incorporate them and they can easily accept it. So rejection means codon bias is literally very low level. And they have relatively small genome, so modification is also very easy and workable. However, one of the important aspects of the probiotic bacteria, particularly lactic acid producing bacteria, Lactococcus lactis in general, they are called group A antibiotics releasing bacteria, because niacin is one of the important food preservatives that we all know that we use. So Lactococcus lactis also produce niacin, which is a small protein, small amino acids, and that can help for maintaining the gut health. But on the other hand, then how the Lactococcus lactis itself survives. So interestingly, they have the intrinsic ability to neutralize the antibiotics by their different immune genes. Among them, NSI1, NSI-EFG, which are majorly the ABC transporter, antibiotic drug ABC transporter genes, which reflects which expels out the excess antibiotics or even the metabolites like niacins. So utilizing this interesting feature of Lactococcus lactis, the first time it was demonstrated by Reuter in 1996 in his Journal of Bacteriology, and he showed and gave us a kind of idea how we can bioengineer bacteria utilizing a niacin-inducible controlled expression systems. So utilizing this system, with the basic backbone, we modified that system in different ways so that the bioengineered bacteria either can secrete the foreign proteins, either they can display on their cell surface, or they express the protein within their cytoplasm. So based on your utilizations, we utilize all three different type of bioengineered bacteria, and we are able to show different targets like influenza virus, and also we were able to express functional cytokines like type 3 interferons, interleukin 17A, as well as toxins from Campylobacter jejuni. So you understand that how heterologous genes can be expressed by this particular gene, and I will give you just one example of how this recombinant bacteria can help reducing the avian influenza virus infection in chickens. So here we have bioengineered those bacteria to express those proteins on the surface. So the green colored bacteria are the bacteria which are bioengineered, and we showed that they also can express neuraminidase, another enzyme, in a functionally active form, which is also very critical for enzyme to be functional because a lot of silations and post-translational modification is required. But this bacteria can express a functionally active enzyme, neuraminidase, as you know, important protein for influenza. When we did a complete in vivo animal experiment with chickens, we showed that the antibody raised against those particular proteins, utilizing this vector, can significantly reduce the viral load as well as raise the secretory antibody response in the gut. Next, if you talk about the cytokines, we also created some bioengineered bacteria with cytokines. We specifically chose to use a particular cytokine, type 3 interferon or interferon lambda 3, for some reason we can discuss later. So again, these cytokines will show that we can they are able to secrete the cytokines in the extracellular environment, because cytokines cannot work in a receptor-bound form. we observe that these cytokines are again functionally active, and in vitro treatment of this cytokine can substantially reduce the viral entry inside the cells, suggests that those those cytokines are functional and they can regulate the antiviral host state. So again, this is a in vivo experiment. Same thing we have showed, and also we demonstrated that utilizing those probiotic bacteria doesn't change the gut in a other way. Rather, as the professor said in previous talk, that diversity is the spice of life. So it can increase alpha diversity and beta diversity with mucosal health. So these two pieces of work we have extensively done, published in some journals. However, there are issues, as Madam said, that there are problems in how we are going to deliver the probiotics. So the right side panel is a problem. And the solution we are trying like coating of those bacteria with some biopolymer so that it can retain the bacteria more time inside the gut, and we check through the in vivo imaging system in mice and chicken model. I demonstrated that coating with this particular polymer increase the retention and interactions with the immune cells. Also, there are other problems. We do not have any control how they are going to express the protein. So, constitutive expressions or chromosomal integration could be the alternatives. We are working on it. And also, there is another issue is the GMO, genetically modified organisms. So, we are feeding the animals and they are releasing in the environment. So, that's again a concern, remains a concern, although they are not pathogenic. So, how to handle this? This is an open challenge, an open question. One way to create the oxotropic mutant. And we also utilize those bacteria to harvest bacterial vesicles. So they are another way that we can utilize probiotic bacteria for mucosal systems. So with this, I will stop here, and I want to thank you all for your patience and listening to my talk. Thank you.
Thank you for your patience. Thank you very much. So, we should proceed. Associate Professor Danta is Goa. So the next speaker is the last speaker in this session. Prita Dutta, who is Associate Professor in the Department of Food Process Engineering in IIT Rourkela. His presentation title is Valorization of Tosan lactate and gelatin in the bioactive food packaging systems. Professor Dutta, please start when you're ready.
Thank you so much, the Faculty of Biotechnology, University of Animal and Fishery Sciences, for inviting me to this wonderful conference. I am Dr. Pritam Sarkar. I'm working as an associate professor. The topic of my presentation will be valorization of chitosan lactate and gelatin in bioactive food packaging systems. So, as you know, the NIT, the National Institute of Technology System, is a chain of university of 31 centrally funded institutes all over the country. We offer undergraduate, masters, and PhD program. And NIT Rourkela is located in the state of Odisha, and it is the only NIT in the whole 31 NITs which has a food process engineering department. So this is our campus pictures, and this is our department where we are present together with the chemical engineering department. Next. So my topic, the research that I'm doing in the at NIT Rourkela for the past few years has been focusing on the food packaging, on sustainable food packaging. So as we all know that the food as we produce is majority, 30 to 40% of that is getting lost all over the world, and therefore we need technical advances in the processing, infrastructure, packaging, and transport to improve the shelf life. So the next slide. The majority of plastic packaging, the packaging materials used in the food industry is primarily focused on fossil-based systems, which is primarily using LDP or HDPE and polystyrene and these materials. But again, these materials, as we all know, they will create a lot of problems because they will be converted to microplastics and nanoplastics, and that will come back to our food system, food supply, and therefore we need to focus on alternative plastics or alternative materials for the protection of our food systems. Thanks. So therefore we want to move away from plastics. Okay, but can we really replace plastics? It may not be possible, but still we are trying. As a food scientist or food packaging people, they're trying that how can we reduce the use of the plastics. Next. So therefore there are a lot of environmental impacts of these plastics because they are not biodegradable. As we said, that these materials, when they come back to the soil, they'll be converted to microplastics and nanoplastics, and they will come back to the food system. So they can be recycling. Incineration is very less. 9% is recycled, only 12% is incinerated, and only 79% discarded. So therefore, the end of life management is not good, and therefore they have a tremendous environmental impact when we are using for synthetic plastics. And we talk about plastics because the food industry is one of the global and is a leader contributor to this plastic mess. So when we talk about active packaging and biodegradable packaging, there's one portion, one section of that which is called nanocomposites. So that is what primarily one of our students is currently working on, this project of these nanocomposites. So we want to add different types of nanofillers to different types of biopolymers from agricultural waste, and then we try to characterize their material properties. So when we talk about these materials, you will see that they have better antimicrobial properties, they have improved mechanical strength, they have enhanced morphological structures, they have higher thermal stability, and they also have superior barrier properties. Okay, so that is the benefits we can add different types of nanofillers to our biopolymer systems. Next slide. So when we talk about this world of bioplastics and biopolymers, it is expected to reach around $45 billion by 2030, which is currently around $17.5 billion. And the market is huge. It has a huge potential in the field of bioplastics. And they are some of the global top leaders of production of bioplastics in the world, which is around 21.6 CAGR. We go next. So our lab is currently focusing on the byproducts or the waste that we call from different toxic sources. So one group has been focusing on the animal side, and the other group is focusing on the plant side. So now today's my presentation will be focusing mainly on the animal byproducts with bioplastics. So if we talk about the meat industry, for example, they have humongous amount of byproducts that are produced, around 100 million tons, for example, and that is going to increase to 130 million tons to 170 it's going to increase a lot. So therefore, we got to use these materials, these byproducts, and it's the best if we can convert them to packaging systems, for example. Next. So for this particular project, we have focused on a couple of molecules. We have focused on gelatin, for example. Gelatin has multiple sources. It's a very important protein from the skin obtained from porcine, bovine, or fish byproduct. For this particular project, we have focused on porcine gelatin. So as you can see, the gelatin molecules, they have a triple helix structure. It's very similar to the structure of DNA. The DNA is double-stranded, but this gelatin is a triple helical structure. And then we have this alpha gelatin or beta gelatin, and then they can be chemically modified, and we can also do some heat treatments and to bring about some improved functionality of these gelatin molecules, which can be used in food packaging. Now the next slide, if you see, we are focusing on another molecule that's called chitosan and lactate. And people primarily focus on chitosan. Chitosan, if you see, it's a material obtained from shrimp, from the seafood, for example, obtained from shrimps or prawns and crabs, and it's classified as a byproduct. And so they extract something called a chitin, and they do some chemical modifications to it. They remove that amino group to get the chitosan, and then you can add lactic acid to chitosan to get chitosan lactate. So for this particular projects, we have been focusing on gelatins and chitosan lactase-based films actually. The next slide. So in order to now we prepare the films, now we want to make these films antimicrobial. So we also want to make packaging materials which are not just packaging materials but with anti-functions. We want to make them antimicrobial functions and also super hydrophobic, also hydrophobic in nature. So we are focused on something, it's a magic molecule, the curcuma. We all know that curcumin is considered as any type of biological activity. You see curcumin, scientific literature has always says that it has one of the best biological functions, starting from antioxidant, antimicrobial. If we talk about the food in the industry, of course, antioxidant, antimicrobial becomes very important parts. It also includes the mechanical, water vapor, and light barrier properties of the material, for example. So we have selected curcuma hydroethanoic extract for this project. Next slide. We have selected now, as we said that we talk about nanofillers, we also want to improve the mechanical properties along with the antimicrobial. So we have selected nanocellulose or cellulose nanoparticles for this particular project. Now, this particular nanocellulose we have got from cotton. So cotton is a very good source of nanocellulose, and then we have used it for this film preparations. Okay, next slide. And also in the last part of the project, we are also focusing on antimicrobial peptides like niacin. Specifically, niacin we all know is the US FDA generally recognized as safe molecule to be used in the dairy industry, like cheese, for example. So antimicrobial peptides, niacin we have selected for this particular project. We'll talk about that. Next slide. And we have selected chicken. So this particular project was actually a India-Sri Lanka project, and which we have primarily focused on the chicken meat as a model food actually. Okay, so we have, and now why we select chicken? Because chicken, as we all know, is a big source of contamination. Especially in India, poultry is in a really bad situation. So many diseases occurs because of poultry consumption. So we need to really work on, as a food scientist, we can think that, okay, so if we can improve the shelf life of chicken, that can have some very valuable input to the society. Okay, next slide. So these are some of the films. So what we did is we took the gelatin and the chitosan lactate and we added them in different compositions, and then we selected the best film formulation. From the best film formulation we added this curcumin hydroethanoic extract. These are the film preparation methods. Primarily it is an ultrasonication based method where high sound energy, high frequency sound waves are used to produce these films. Okay, next slide. So these are some of the rheological, some of the characterization methods that we have performed for all these dispersions. So we have characterized through the flow curve and frequency for rheological properties, the physical properties, thickness, moisture content, water solubility, surface hydrophobicity, very important for film characteristics, mechanical properties, so tensile strength, elongation, break, elastic modulus, stress relaxation properties, optical properties, because when you talk about the packaging material, the color property of the packaging material becomes very important, how it interacts with the food. Then we talk about barrier properties. Primarily we talk about water vapor transmission rate. There is another barrier, that's OTR, but we don't have the facility yet, but we could get the WBTR data. We also did the molecular level characteristics of the film, starting from crystalline property, XRD, FESCM, and FTIR. We also did thermal properties for the DSC, then biological activity, antioxidant and antimicrobial activities, and we applied that to those particular films to wrap a chicken meat, and then we wanted to characterize how the chicken meat actually interacts with this gelatin chitosan lactate based films, and we did some characterization like hardness, pH, weight loss, T-bars, and PVC. Next slide, please. Okay, so these are the raw materials, and these are the raw materials, some of our characterization. We did some XRD profiling, then we did FTR profiles, and then the Karma DSC profiles, the FESCM profiles. Next slide. From that first evaluation of the raw materials, we selected the best material, the best film. If you see, there are 5 formulations we took, starting from 2.5 to 0, and then 2 to 0.5, 1.51 to 1.51, 1.5 and 0.52%. So we found that the middle one, center one, provided the best optimized property amongst all these film formulations. So based on that, we proceeded forward. So we selected that particular formulation. And next slide. And then, so we select that particular polymer film, and then we load the curcumin hydroethanoic extract into the films, into the third film, and then we gradually increase the concentration of the curcumin hydroethanoic extract. And then we wanted to study how that curcumin can actually interact with the polymer and the polymers. Next slide, please. So these are some of the rheological characterizations of the film forming dispersions. So first we mix the biopolymers, then we make the dispersions, and then we cast it into the film. So these are some of the rheological characterizations of the film dispersions. Next slide. Physical properties, if you see the thickness, there is some differences between the 2.5% gelatin with curcumin C to 200%. The moisture content was significantly improved from 9.25% to 24.52%. Water solubility, there is also an increase from 43% to 58%. But when you add the CE, if you see there is an increase because curcumin is primarily hydrophobic. And the contact angle, which is it gives us an indication of the surface hydrophobicity, it reduced initially from 87.2 to 63.8, and then there is a significant increase with the addition of curcumin to 19 degrees, which is what we need. The next slide. These are some of the optical properties for the films. We characterize through the LAB, the Hunter lab colorimeter, the total color change, and we also characterize the films through the UV transmittance spectroscopies at the UV range and at the visual range. The next slide. We also did because when we talk about packaging, the material properties becomes very important, barrier properties becomes very important. We talk about tensile strength, Young's modulus, elastic modulus, the elongation break, and then we did some extra analysis that is called the stress relaxation analysis of the films. And then from that we did the mathematical modeling. This is a V-shaped modeling, which will give us some idea of the viscoelastic nature of the films. The next slide. And these are the morphology of the first 7 or 8. The first 7 will give you the idea of the surface morphology of the films, and the next 7 will give you the idea of the cross section of the films. Okay. As you can see that there is, as we add the chitosan, as we increase the chitosan and gelatin active concentration, you can see the differences. Okay, next slide. These are some of the molecular level characterization concerning FTIR, XRD, and the thermal properties, DSC. You can see there were some differences in this particular title. You can see not see some. 5 minutes? 4 minutes, okay. Next slide. Okay, barrier, antioxidant, antimetal properties. Next slide. And then the application part. So we selected chicken, specifically chicken for this particular project, and then for to study how these films can really apply to the chicken meat. We studied color changes, and next slide. And also some physicochemical properties, surface hardness and pH. Next slide. Okay, so this work was published in the journal Food Hydrocolloids. Next slide. Okay, the second part is briefly I showed that we wanted to further improve the mechanical properties of the films. So we wanted to add this cellulose nanospheres, which is obtained from the cotton. Next slide. Okay, again same properties that we did. Next slide. Next slide. Okay, so again the raw material characterization, the 10 micrograms of the cellulose nanospheres. You can see almost they are less than 100 nanometers, 50 to 70 nanometers. Next slide. We also did some Raman spectra of the cellulose nanoparticles and the chitosan lactic gelatin. Next slide. Rheological properties of the film forming dispersions. Next slide. And this is how the films, when we add the cellulose nanoparticles, how they actually differ from the initial particles, the differences. And also you can see that when you add the cellulose nanoparticles, it can actually very easily peel out from this castings, the solvent casting plate. The next slide. The physical properties, thickness, moisture content, water solubility, contact angle, we measured, so 96 degree. Next slide. Again, optical properties, mechanical properties, you can see the differences. Next slide. So morphology, both the surface and the cross section of the films. So next, please. FTIR and Raman spectra. Next. DSC and the XRD profiles of the films. Next. Again, barrier, antimicrobial. You can see. Next. And we also studied, so as we add the cellulose nanoparticles and as we add the curcumin, so we wanted to profile the release, how this curcumin is actually released from the films. Okay, so we also did that, and then we followed this particular, Nicholas Pepper's model we used, the power law model, which is a very common standard model for characterization of these films. Next slide. And then we also had, so this CNS, the cellulose nanoparticles added films we wanted to apply on the chicken meat. Again, we did day 3, day 6, day 9, and day 12 studies. Again, compared to the day 0 studies. Next slide. And again, you can see this. There are some significant differences in terms of total viable count with the pH and the surface hardness of the chicken samples. Okay, next slide. Okay, this work was recently accepted in ACS Food Science and Technology Journal. Next slide. So these are some of the news releases we got based on this packaging work in the last 1 year. Next, please. And these are some of our academic collaborators. Next, please. Our students, this is actually the work of Rahul, this fourth student Rahul Thakur, who is currently going to submit his thesis, all his thesis work. Next slide. Our funding sources, NIT Rourkela, SCRB, DST and Spark. And next please. Thank you.
Thank you very much. And so, I apologize for the time management of this session, but I'd like to close this organization with applause to the all very excellent speakers. Thank you very much.
Ladies and gentlemen, we now come to a special moment of appreciation in this technical session 4. On behalf of the organization of QOPS SASNetCon 2025, we sincerely thank the Honorable Chairman and Rapporteur for their invaluable guidance, scholarly leadership and support throughout the session. It is our privilege to felicitate our respected Chairman, Professor Kenji Fukuda, for his inspiring stewardship and academic contribution. I request Professor Bhattapal Sir to felicitate our Chairman Sir. And also we want to felicitate our Rapporteur Madam, Dr. Sarita. I request Sir again to felicitate Madam. Thank you, ma'am, for joining us here as Rapporteur. Thank you, sir, Bhattapal sir. Now, I request our Chairman, sir, to felicitate the invited speakers of this session one by one. Anamika ma'am, please come. Dr. Anamika Deka. Give a big round of applause for ma'am. Next, Dr. Subroto Hati. So a big round of applause. He is also the joint organizing secretary of this SASNetCon. Now, Raghu HB, Dr. Raghu HB. Dr. Aminul Islam Malik. Dr. Joyita Bhomi. Dr. Pradip Denge. Dr. Pritam Sarkar. He is also our alumni of this faculty. So Pritam, please come. Thank you all for your attentive listening. We will start the next session from 12:15. So 5 minutes break for tea. So please, I request all to gather in the lawn and have tea, and we will be back here within 5 minutes so that we can start the session in tight time. Thank you all. So next will be industrial session. So we'll be here.
Thank you. ভালো লাগলো স্যার ম্যাডাম বললেন
शिशु अरे कम
वो बिजी रहता है क्या
why no
ক্যামেরা বন্ধ করবো, এটা বন্ধ করছি। থাকবে? হ্যাঁ হ্যাঁ।
industrial session. I would, she has explained everything why chairman is not coming. Now directly we are in rush, so I will directly invite our first speaker, Dr. Sumit Datto, to give his talk. Thank you, sir.
A very good morning to all of you. First of all, I would like to convey my sincere thanks to the organizers, ASNET FF, for inviting me and share my thoughts and whatever work we have done in the area of startups and how, the gut feeling for us is that the startups are changing how we eat. There's a lot of startups are coming up who are actually changing the consumption pattern and consumption habits of consumers. So on that aspects, I'm going to give my talk. Other than that, I would also, it's a very nostalgic moment for me also, because I have done my undergraduation from this college and coming back here after a long time. And I also really like to mention that not only the organizers, the students are wonderful in arranging this whole program. So I really appreciate that. Coming to my talk, first of all, why we are talking about this, these startup things, and before that, I'll just give my background. I'm basically a dairy technologist. I've done my master's in dairy chemistry from India, Karnal, and after that, I have done my MBA and PhD in management. And right now, I'm working as a principal and dean of a college in Anand Agricultural University, Food Processing Technology College. But other than that, I also performing a role for last few years, and as an executive director of a company, Section 8 company in the university. So, which is a very unique role for me. And but this kind of roles are going to come in future also. So here I'm not rightly I'm not going to talk about the technology aspects, mainly about the business aspect of it. I'm also heading the Department of Food Business Management in our college. So why this is becoming important? This fermented food, why it is becoming a potential area for working by the startups. So as we all know that the rising digestive disorders are there, lifestyle diseases are coming up. India is the capital for that. Growing awareness for gut-brain immunity link. So that is also becoming very important in many oral presentations. Yesterday's initial talks also by Mr. Ramesh talk, he has very nicely mentioned that. Shift from reactive healthcare to preventive nutrition, that is also happening. COVID has actually been, before COVID, for many years, we technologists, those who are working in industry, we went on telling that consumer is not aware about the health aspects of food. They are not ready to pay more. That scenario has completely changed after COVID. Now consumer is ready, is demanding the products which will have a very defined particular nutritional aspects in the product. So industry and the scientific community should be ready for that. Other than that, demand for clean labels is becoming very important. Natural, health, green labels, functional foods, all these things are also, consumers are becoming aware more and more. And fermented foods re-entering the mainstream. So these very, very important aspects. We have discussed in many presentations also earlier that fermented food actually was in the domain of traditional food products, right? It means it is a homemade product. I would just like to share, previously before joining academics, I worked in National Dairy Development Board for about 13 years, where our main role was to transfer technologies. And I still remember in the year of 2000, 25 years ago, when we used to go to the factory to take a DBS culture for manufacturing dahi, no MD was ready. And the standard answer was that dahi cannot be sold. It cannot be sold. I'm talking about 2000, not very even in this century only. And every MD will tell that dahi cannot be sold in packets. Dahi is something where our emotions are attached. The housewife will put it in the evening and at the time after dinner, and in the morning we'll get a homemade dahi. People will not take dahi as a packaged commodity. The scenario has been completely changed in 25 minutes. It took actually 15 years. when Amul and Mother Dairy kind of companies entered with big muscles and marketing, whole scenario changed. Now there is not a single cooperative dairy who is not manufacturing lohi in package as a packaged commodity. So this kind of change is possible in any product. So just we need a proper direction, vision, and a plan for that. Of course, with marketing and business aspect involved in that. Otherwise, we will go on doing science, but if it is not reaching the market, there is no value for that. So science. Another thing is very uniquely happening. This is also a post-COVID phenomena. Science is coming with a lot of overstatements. Means you can see every day there are WhatsApp messages. Functional food is one area which is, as because it was traditional, as many participants from Northeast has mentioned, in Northeast every village has a new product in fermented product. So those are very small scale. Business cannot be done in that scale. We need scale to have a proper business. So for that purpose, we have to understand that there should not be overstatement with science. These two cannot be linked for a business. So gut microbes influences digestion, immunity, metabolism, inflammation. These are very well established. Fermented foods introduce beneficial microbes and bioactive metabolites into our body. Role of probiotics, postbiotics, organic acids, enzymes, all these things are coming up with more and more science establishing those things. But importance is strain specificity and dose specificity. If I will say that this has some microbes, so it will help you, it may not be. So how much dose should we take? Whether it is written on in the pack or not. So consumer will more and more will ask for dose specificity about strains and doses. So what are the startups are what? Startups, how it is different from a normal MSME company or any other company. Startups means innovation is linked with the business, right? So basically they are disrupting something. Means if it is a normal business, if I am just selling liquid milk, it cannot be a startup. So there should be some amount of innovation has to be attached with the in that business. So innovation pathways in fermented foods, how it is taking up. So basically there we can categorize it. I will categorize also. Mainly we will see the number of startups who are coming in the fermented food areas. Mainly there are 3 categories, but they are working mainly on the process optimization, means temperature, pH, aeration, inoculum designs, all those things. Strain selection for desirable flavor, stability, shelf life, means that what do you call them? These ATS producing bacteria which will actually limit their growth. So that kind of things are also happening. Continuous fermentation systems improving consistency, and then application of bioreactors, automation and live monitoring systems which are more technology involved. So these are the general pathways, innovation pathways for startups. We are looking for this area. Fermentation, we know it's from tradition to functional food. There is a change. Means initially it was a traditional food. Now it has become functional food. India has a rich heritage of fermented foods, and going beyond to dairy, there are many number of products, food products where fermentation is happening. Starting from curd, kanji, dosa batter, chas, pickles, and many more. So what startups are changing actually? They are standardizing the fermentation procedures, hygienic and safety, they are bringing it. Shelf life without preservative, that also there is a claim for that. Consistency across batches, uniform productions. Delivery of the multiple product innovations in RTE segment. So consumer is also looking for convenience, so that also they are bringing. So so what are the pathways the startups are changing it, the pathways they are chosen. There are I categorize them in 3 categories. One is scientific translation. Some startups are really working on those areas. Some are actually working on the technological enablement. And the third one is socio-economic value chain creation through startups. So these 3 pathways normally they are following. So we'll go into details. I'll try to give at least one example from each of these. So first is the scientific translation. So we're moving from the anecdotal benefits. So we know that there is certain benefits, but we are converting into a measurable outcome where we can actually understand this much dose will give me this much benefits. So that kind of things, many startups are working on those areas. Microbiome profiling, metabolite analysis, biomarkers, these are the areas where startups are working. These are all scientific translations basically. And need for clinical relevance, not marketing claims only. Where clinical relevance are there, so that also they are highlighting the new startups. Collaboration between startups, universities and clinicians are also. taking up. Second is technological enablement. Many startups are actually, it is easy way to go for a market with a fermented product, where basically it is a combination of engineering and food science, where there are controlled starter cultures, rapid microbial assay, cold chain integrations, automations, bioreactors, incubation control, HACCP and regulatory alignment. Those things are happening in this space. Third one is the socio-economic value chain. So there, especially some startups in Northeast already have come up. In Calcutta, there is one good startup is working. So who are actually working mainly from an angle, from the socio-economic value chain, value creation angle. So fermentation has value addition to milk, vegetables, grains, linking farmers and processors and consumers, reducing waste, better utilization, local sourcing, and rural livelihood, means connection of rural livelihoods with the gut health markets. I'll just like to highlight some of the case studies. One is the Eat Fresh. I think many of you may be knowing it. It is already in the market, means in the e-market it is available. So how the story is how Eat Fresh started. Eat Fresh started in near Bangalore, one city near Bangalore, I think in Mysore only. So Mustafa is one person. So he was not very wealthy family. He has 4 cousin brothers. So they were trying many things, failing. So sometime back, so they decided they put 50,000 rupees, 50,000 rupees each of them. So 2,50,000 copper they created. And with that, they just decided, because idli is so popular there, dosa and idli, so on the batter we'll try a startup. So their focus was on the area that they will not add any preservative. It will be as natural as home. So where they can focus? So they mainly focus on the packaging and the logistics. And now it is a big business. Means even in, I think in Calcutta also it is probably available in the LinkedIn and all. So it has gone up to that scale. So it is possible in the fermented food products also to make a big business is possible if you have the right kind of vision. So here in this particular thing, why it is a technology enablement, they have not done any big scientific translation. They have just focused on the technological enablement. The technology was already there. They have enabled it, they have scaled it up. And ultimately packaging innovation was a key differentiator here with the normal regular other pattern sellers. Second example I would like to give about the Epigamia. You all know that he expired 1 year back, right? Who started in Mitchell and Rowan Mitchell in Bombay. So there also they have actually focused on scientific transmission also. They started using the fresh fruits in the yogurt product. They actually first started with the Greek yogurt, then they went to the other products also. And now its valuation is very high, means even after there are some challenges, but it is a successful startup who has got a lot of fame, a lot of money also they have taken. In the startup, the first thing is that some bootstrapping is required, but nowadays government has many schemes to support the startups as a seed funding. So all of these companies first taken those seed funding, they've gone to a particular level, and then they have actually gone to the investors. So where these kind of companies have got very good amount of money, and their product means differentiators were mainly texture, shelf life, and probiotic viability. So those things they have worked on. Third one is a Calbrew. It's a Calcutta-based company, Calcutta-based startups. I think at the time of COVID only, four ladies, means young ladies rather. So they actually decided that we should work on these areas like kombucha. And we started with kombucha actually, and their main focus was to target the fizz drinks like Coca-Cola and Pepsi. We all know that these are not good for health. So they thought there is a market where we can give a product which has fizz as well as health benefits, so that it will have a market. So they started working on it. Now it has gone to a level. So this is a Calbrew. It's a Calcutta-based company only, so it is possible here also. And they are using local fermentation with modern disciplines, modern systems. Those things they have incorporated. The fourth one is actually a startup. So fourth one is called the Leumas. So Leumas is a startup which is incubated by our company, by our university only, our incubator only, our Section 8 company. This Leumas is a wonderful story. Means there are two persons involved in this project. One of them is a Bengali. He has done his postgraduation from IISc Bangalore. and he found out one area where means next generation robotics, nano factories can be a solution. So he has actually, using robotics, he has developed a nano factory. So anybody, means this kind of companies, now there are a number of companies who are working on nutraceuticals, maybe fermented, dried products. So mainly for the dried products, you can just program it, you have to give the different ingredients, it will give you the product. And in a scale, this nano factory now has actually gone to micro factory. He has now rented one floor of his factory to a ITC for trying their new product. So where a new company need not to invest any money. He is providing the factory, and these are micro and nano factories where different combinations can be tried. Because this particular market is very rapidly changing, you need a lot of products. It is not only one product. Amul is selling butter, it will go on selling butter. It is not like that. Every day you need a new product, new formulations, where it can be required for a customized product where the scale may not be that high. So for those companies, this has become a very, very good solution. So it is a robotic enables production, and probiotic powders, gummies, they are working. I'll give the examples. Means this Lumus is our incubated startup. However, there is another startup called Shobha Health. It will come in your Facebook and all. They are very active in social media. Shobha Health is actually using their facility. They do not have any manufacturing facility. They are completely using Lumus facility and marketing products. Shobha is started by a person called Tanveer Singh, who is an ex-tennis player, national tennis player. He felt that our gut, means Indian gut, has to be addressed more. So first he tried to get his app-based kind of startup. They tried to get the data of Indian gut. So what microbiome are present there. So that collection he is doing, and he is giving customized solutions. So he get it tested, so it comes with a chart. But for that purpose, he needs a particular solution, means particular kind of product. So for that, he is using this kind of micro factory. So Shobha is also a successful startup story who is using Lumus. Now coming to the, so this particular machine has a flexible volumes. It has a complete cost control. Means you can actually order any kind of scale is possible. Faster lead times, within 5 to 7 days they will deliver the product. One machine we are planning to put in our university also. We are in that because it is incubated by us only, and very low investment is required. Now coming to the another kind of incubation, means we are not incubating startup cultures, we are not incubating cultures, but we are incubating actually startups. And as the microbes can bring a change, can change a liquid milk to a gel of dahi. So similarly, business can also be changed by the hand-holding, by the incubators. So that's what we are doing. So we are trying to bring changes. So for that, this AIC, it is Anand Incubation Center, means it's a AU promoted Section 8 company. So basically, we are working on a 360-degree approach to startup success. Means reducing reasons for failures. It is a complete 360-degree approach. Means we help the startups in any way. Means it is not only technology. Means what happens that many technological universities, when they start the incubators, they only restrict themselves to technical aspects. They have a lot of facilities, they allow them to use those things, that is fine. But in our especially agri and food startups, they need more than that. Not the technical support only, they require support in terms of business acumen. So there also we provide support. We have a very 50+ mentor group who train them. We are running a lot of schemes also. So this is our incubation center, which is inaugurated by Honorable Prime Minister in 2018. We have in food production, we have 8 lines, 8 complete lines starting from extrusion, from IQF, from frying lines, bottling lines. So all those facilities are there. This started actually as a ELU project, as in many universities that are happening, but then we felt that these facilities cannot only be used by the students, so we went for the startup projects, where actually our incubators can also use them. Other industries can use the facilities. So when we have a facilities, when university creates a facilities, if it is not utilized by the industry, then it is really become very difficult to justify the utilization of those facilities. So that's how the startup projects we started, and now it is a very successful one. We have formed this Section 8 company in 2022. I am also working in the capacity of as an executive director of the company. Where right now we are running 3-4 government schemes. One is RTPI Ravi Raftar scheme. We are also working on the startup support schemes of Government of Gujarat, and Gujarat government has a wonderful scheme of SSIP, Student Startup and Innovation Policy. These kind of policies are really helping the startups. Recently we have disbursed about 12 lakh monies to our students only. Our MTech PhD students, whatever work they are doing, we provide up to 2.5 lakh support to the student himself just by a committee to convert his idea to a proof of concept. Not in a startup, he need not to form any company, but whatever research he has done as a part of his curriculum, that can be converted to a proof of concept. So for that we provide up to 2.5 lakhs support. So that is also helping. So say these changes, this incubation is not like converting milk into dahi. This needs more time. We have to be persistent with the startups, but then the changes will bring, and which is really required for this country. Our impact of this EU Incubation Center is till now we have incubated 247 agri-food startups. Out of that, 50 plus startups are women-led. 35 startups, new products have been launched. Our startups have been featured in Shark Tanks, and 800 plus employment has already generated by these startups. Total rupees 5.81 crores we have disbursed to 67 startups from one of the other schemes. So some of the startups are really doing very, very good. You can see the names of like that peanut butter companies. There are fermented companies, fermented food companies also. So they are doing wonderful jobs. So this is the story. So because I thought to share it here, because I think yesterday also there are some queries. Madam was telling that how to take it into the industry. So this can be a wonderful avenues, and anybody wants to collaborate with us, we are open. And from university angle, this kind of Section 8 companies ultimately helped us. We are working on it since 2007. I am working with this project startup. But initially we faced a lot of problems because our university setup never allows us to work in a startup mode that fast and giving the money, and also that's why with our Honorable Vice Chancellor, he was very supportive, and he actually allowed us to form this company, Section 8 company. Now it is really working very good. So I thought to share this in this forum so that people can take benefit. Thank you.
Thank you, sir, for really knowledge enriching talk on startup in fermented food. So it was really.
We will take the question later once all the lectures are over.
Okay,
Thank
fine.
you. I sincerely apologize for one thing. I missed your biodata. You have already explained. Thank you.
Thank you very much, and a big pardon from my side. As a matter of fact, my road got stopped for some VIP. 20 minutes I was stuck there, and thereafter began. Anyway, we have started. You have heard a rare blend of science and business from Saugata. Sumit, I'm sorry, Saugata is coming. So he has done some. He has shown us some pathway for the students, particularly how we can go ahead. Anyway, I will not take much of time. Now this is time to hear one of the greatest visionary of dairy. He is an expert. He is working for more than 30 years with very, very rare kind of experience in research and industry. He himself is an institution by now. He has all the accolades that is possible on earth on his cap, and he is none other than Dr. J.B. Parekh. So, ladies and gentlemen, keep your belt tight. Here is Dr. J.B. Parekh.
So good afternoon to all of you. First, I would like to thank to the organizers, particularly the Vice Chancellor, Dr. T.K. Mehta Sahab, and his team, our Dr. S.K. Bhaga Sahab, and Dr. Rupa Gudra, and also from the center, Dr. J.V. Prajapati and Dr. Hathi, to invite me for this type of wonderful International Conference on Fermented Products. I'm really thankful to you, and I think we are enjoying for 2 days, very nice. I mean, learning also as well as the fellowship also. So now my talk will be very much something to review about the dairy industry first, and then we will show some of the things, what is the flow diagram of some of the products that can be available in the market and can be also manufactured. So just I will start, the dairy industry as a whole is on next slide, please. So just I want to summarize for the dairy industry as a whole, how things are moving in the dairy industry before we go with the fermented dairy products. So you can see the population is now about 140 crores and farmers are about 8 crores, and you can see that milk production is also about 239 million tons per hour. Livestock is also contributing about 36% of the GDP. And lot of scope is there for the employment also, and there is also a lot of population of the buffaloes here also in India. So I think there is a lot of scope for this dairy industry as such where we are growing. Average annual growth is also, you can see the 7.9% is there. So these are some of the things I want to show here. I can see here also. So per capita of the milk has been also increased now about 493 grams.
Sir, you can see the front.
Yeah, it's not very clear. And the boiled poultry population is about 30 crore. So there are some of the daily scenarios. Can I next slide?
Next slide. Next slide.
Put like this. Yeah. So this is how the milk animals are about 112, crossbred cows about 35 million, indigenous cows 30 million, buffalo about 60 million. Milk product is still low compared to the other countries, about 200 liters per liter. And cattle feed is about 6 million, which is also being required in the shortage of the cattle feed also. The total processing plant is about 2,300. Which is producing about 30 crore liters of the milk, which is contributed equally by the private sector as well as the cooperative sector. And they about 35% is total market level surplus. So 1/3 depends on the milk producer, 1/3 is depending with the sort of unorganized sector, which is a really challenge. Whatever the 135% comes out from the organized sector, what we call, about 50%. So this is the present scenario, how it is working. Next please. And this is a little bit old slide, but this shows availability of the particular milk, or you can find the eastern zone is really deficient in the milk. Now I think West Bengal is about 3.2% total of the milk production, which is about 12th in the milk production. So this is just I have an idea about the things. You'll do, but now.
Why don't you operate? Operate from there.
Yeah, I think that will be better. So here you can see that the total availability I have shown it from starting from that Rajasthan, again now it is a UP, is number 1, which is contributing about 50%. And the West Bengal is about 3.1% now, total contribution of the milk in India. So this is a present scenario, but as I mentioned to you, we are growing very fast in our milk production, about 6% is the growth. Then I have shown state-wise major states of the growing this milk production, including Uttar Pradesh, Rajasthan, Madhya Pradesh, Gujarat, Maharashtra, and other states. So other states is about 46%, and about 54 states are covering about 54% of the total milk production in India. So this is a state-wise process. Now I'll show you something. Earlier slide also. And this also shows the different paintings of how the women are consuming the milk and milk products, particularly curd and the milk. This is also shown, and you can see that total consumption in the eastern part is very less compared to the balanced part. Next, please. Now, market size of the dahi, you see that market size is growing very fast. It was now 1.78 billion by 2024 last year, which is a growth about 12%, which is maybe about, you can see the growth will be about 5-4 billions will be there. And then we again market, which is one, the cup card and pouch cards and other sales. A lot of institutional and retail sales is also growing up, so there is a lot of scope for this type of products in India is growing. Next, this is about our India side. And then you can see that the West Bengal also now is reported recently about 12.3% is growing in this. And you can see that total is about 890 billions worth of the market, which is about 8 to 10% share of the total milk in the curd available in the India. So this is how the things are going very fast in terms of availability. And in the Bengal also can see the new infrastructure. Aninghata is now not much working, but other processing plant, automation and things, other things are also processing the production and growing very fast. So I think there is a lot of scope for these type of the products, maybe yogurt, butter, or there is a huge potential for the rural livelihood uplift and the growth in the dairy industry. So I find there is a lot of scope, output looking there for the, particularly in the West Bengal. Next please. Now you can see that again a large part of the dahi market remains unorganized field. I think organized sector is handling only 6-7% of the total what the consumptions in the curd market in India. So this is a preparation is made by at home also and from the local dairies. The organized sectors are there are many, and I'll tell you accordingly. The Amul's and the Red Cow, so many other brands are also available, and the Milky Mist, so many brands, which are also growing now very fast, and there is a lot of scope, including the Nestle's, multinational, they are also in the products. So there is a lot of growth is there, and it's remaining very good traditional and backbone. But as I mentioned to you, most of the curds still remain with the unorganized sectors, or maybe by the made at home. Next one. Now the trend is changing. You can see that growing the interest in the probiotic health-oriented curd. Many consumers now look for the very support digestion for the general health public, with what we have got slogan also here, our theme of it also, which also helps, and there is also increasing the flavor type of the low products, the other things. So there is a lot of scope. And also there are a lot of challenges are also there. You consider that this is what I was trying to tell you. Yeah. 1 minute. So this is what I want to show you, how the yogurt market is moving for both and establishing growing very fast. Now we'll go to the different types of the yogurts which are being mainly prepared. That type of the incubated also in the packaged forms. The third type of the products incubated in the tanks and cold before the packing. This is mainly for the lassi or drinking yogurt type. Then drinking type of the similar stir type of the yogurts, which have been broken and which have been broken, and frozen types. So they are some of the products generally classified in the part of the yogurt. So these are also now coming up trend in a very fast. Next please. So this is very important for us to make the good quality of the fermented product, long life product. The quality of the milk is very much important for making this type of product. Bacterial quality is also important, low content of the bacteria and also other substances which impact the development of cultures, mainly antibiotics, bacteriophage or other residues of the CLP. These has to be taken care when you are selecting the, particularly milk for making the good quality of the fermented products. Next please. So yogurt is a great source of all the culture milk products and it is most popular almost all over the world. Consumption yogurt is highest in other countries around the Mediterranean, Asia and the Central Europe. But now you can find a lot of yogurt products are also now manufactured in the organized sectors. Next please. So this is what I have shown you, some small flow diagrams where you can make some of the, starting from the heating of the milk. Okay. Yeah. Then this is just a plain yogurt. Processing is shown, maybe useful for the students to understand how pre-heating, filtration, clarification, starting pre-heating, homogenization, pasteurization, cooling, incubation, tracking, and inoculation and the culture and the tracking and then incubation and finally putting in the store. These are the steps are involved for making the plain yogurt. When we set the curd in the cups or in the containers after addition of the culture. Next please. Now we have also flavored yogurt which is flavoring and the aroma additives is very popular along the trend and toward the natural yogurt is visible in the market. Common additives are fruits and berries or syrups are also added. The proportion of the fruits are generally 50% and 50% is sugar. So these are some of the flavored yogurts are also now available in the market. Next. So again I have shown that the flow diagram for the manufacture of long life yogurt which is not very good for the gut, but we are taking the fermented product for more for digestion and for enzymic other. But when you do some treatment, UST treatment or sterilization, some of the heat sensitive products or bacteria get died. So this is just I have shown to some of the countries like in India also we have long life plus other things. So these are some of the things I have tried to show to make these products available. Next. So we can have all type of flavors, maybe coffee or vanilla, coloring, sugar from sugar. These are some of the additives also we are adding to make the product more flavor and stabilizer also. This is a general practice of the hot yogurt type of the products are manufactured. Next please. And this is also a fruit yogurt where you can mix up the fruiter. Separately packed in the tin cups also available. Sometimes you can mix the fruits together also or keep it separately. And when you are eating, you can mix the fruits. So what we call big cup, that will also be developed now. Next. Now this is a set yogurt. Generally what we are calling set dye. It is very similar, but there is a different type of microflora is there. So this is incubated until it reaches the consumer, it kept in it. It's making the set yogurt milk protein intermediate for consistent jelly. Hence milk proteins or some of the other additives are also added to improve the body and the texture of the products. Next please. Now just I will try to show you the flow diagrams where you can have a set yogurt, where you can have a culture, you can add in the milk, and then you put the incubation room, and then after incubation you can go for the rapid cooling, what we call fast cooling. So here the culture is added, then the cups or container they are put in the incubator room, and finally after bird is sad depending on the temperature. It has to be quoted in the Okay, next please. So this is again basically shown the four whole line in terms of the shared yogurt, where you have some basic processing, and afterwards you can bring the milk to the incubation and do cracking in the cups, and finally it goes for the incubation. So this is a particularly flow diagram for making the shared products like dahi or like a yogurt. Next please. Again, I will not take more time, but this is also flow diagram for making the shared yogurt. You can see that temperature you have to adjust the pH and the temperature is very much important. And then you have blast cooling, and then you can put in the cold storage. Yes, please. Now we have got also the stirred yogurt, which has a creamy texture, which gives fruit also we are adding here. And this is also extra bit, we can increase the protein level also as stabilizers for making stirred yogurt. So this is some of the what we call the high protein yogurt also. This is also very popular now in the market. Next. This again I try to show the flow diagrams. One is a fermented tank, then is again immediately cooling, and then you can have a cup filling machine. So this type of products are also becoming popular. These are very compact machineries that are available now in India. Next. Then I have shown the same thing with the stirred yogurt, where you can have all the tanks is full, and then it is incubation tanks are there between. You can see that, and then it goes for final for the cup packing. Again, same thing is there. The flow diagrams, and this is the final you have to put. Sometimes you have aseptic packing, which is more like maybe 1 month under the cold conditions. Next please. Now this is a general flow diagram showing different products, drink type, stir type, and the set yogurts. As I mentioned to you, when you can have incubation is done in the cups after filling. And when sometimes the milk is incubated in the tankers and then stirred like a drinking yogurt or like a lassi. And sometimes we give the USC treatment also, those who want to have a long life product. So these are different types of the flow diagram. Next please. Again the same process I want to skip now. Next one. Yeah, these are all three alternatives are there. Sometimes you cool it, you don't pasteurize it. Sometimes you pasteurize and do the ESL type of packing, where you can have a life about 1 month. And if you want to do also aseptic, then life could be about 3 to 4 months. Next please. So sometimes we also have a concentrated, high consistent product also, where you can use the ultrafiltration methods, membrane technology, where you can concentrate and then you can do the cup filling machine, and then it goes finally for the incubation. Next please. I will not give much time, but these are all the fruits and flavor are also ordered, which is becoming very common now. So next one please. Now Lactalis has recently developed it pro fiber yogurt also, where you can have a level of the fiber, it can go up, 20 gram protein, 10 gram of the fiber, and 0 added sugar. So these are some of the pro fiber yogurts are also available. Recently Lactalis has launched these products. Next please. Lactose free product, most of the, when you do the fermentation, lactose get hydrolyzed. But some of the still, if you want to hydrolyze, some of the enzymes are added, and accordingly you can completely hydrolyze the lactose, and then you can have products, yogurt free of the lactose. Next please. Now this prebiotic is also now coming very popular, and today also we are discussing about the prebiotic bacteria, and particularly lactobacillus, acidophilus, and the placentum, so many other bacteria are available. And which are added to to the yogurt also together with certain culture milk before the fermentation. So these are some of the probiotic products are also available in the market now. Next please. So this again a culture product I showed you very basic process to make it processed milk suitable for the making the any fermented products where we can have a holding also more time, maybe 3 to 4 minutes, and we can have also deodorization, and you can remove all the off layers, homogenization, milk get ready for making some of the products. Next please. Now what are the factors about the affecting the quality of the yogurt? So choice choice of the milk is very important. Standardization, choice of the ingredients, what you are putting in, maybe deaeration, homogenization, heat treatment. We heat at higher temperature also, then you can have this type of product, and right of the culture and the plant design. These are some of the factors which is affecting the quality of the milk, yogurt. Next please. So this is basically we are increasing the content of sometimes also fat also, but generally it is a high protein and less fat products, which is epidemic type also. The other products are now coming up very fast, developing the market. So this is seems to be a very good market in the future. Next please. Greek yogurt is extensively used with liquid ways. So this is also where you can remove the lactose and replace either by with ultrafiltration method or with hydrolysis, and that can be added with some of the proteins in this, and that can give you high protein product with a less sugar. Next please. So this is also some of the methods that we show on how to increase the protein level, maybe up to 10%. You can have add some protein powder or ultrafiltration method or separation. So some of the methods are shown here, with which you can increase the level of the protein and reduce the lactose level. High protein yogurt. Next please. So this is our traditional dahi I have shown, which takes about 16-18 hours. Generally, what is the home practice is going on now. Everywhere, this is how generally standard we follow this. So now this is that also whatever dahi available in the cups or in the pouches. This is what method we are following. Next one. Now Amul has recently launched this high protein probiotic dahi also. If you have multiplied both with the high protein increase also with the probiotic. So this use about 6.3 gram of the protein per 100 gram, which is designed to help you meet the daily protein requirement. Right, we know there is some protein deficiency there in our India. So these are of the products are very good, and they have got also probiotic bacteria also. This will also boost protein and the probiotic both. So these very good products are also now Amul has launched recently. Yeah, next please. So this is again a lassi or whatever we call drinking, where we can have an inoculation. First we do the inoculation, then we do the incubation, and then we can have mixing of the sugar or salt or flavors and homogenization and packing. So this type of lassi is very common, maybe spicy, salty lassi or with a sweet lassi depending on the requirement, and there will be different flavors, maybe rose or other things, or sometimes they add the dry fruits also. So this is also become very popular now, lassi, similar to like our drinking yogurt. Next please. So this is a long life lassi. Then again you have to do the aseptic treatment basically. With after all the mixing, homogenization, UST and finally aseptic packing. So this gives the life of the lassi maybe 4 or 5 months at ambient temperature. This is very important. But as I told you, most of the nutritional value, particularly enzymes, they get lost, bacteria, food bacteria also get lost. So those who want to have a long life products or want to sell far distance, they might think about this lassi. Otherwise, we don't recommend for the fermented products to do any long treatment or heat treatment or aseptic treatment. Thanks. Next one. this is also I tried to show on the left hand side. You can see that making the simple dahi, and the right hand side you can see both these things are there. With the lassi also aseptic lassi and non-aseptic cold chain lassi. So these are some of the flow diagrams which is in our industry is adopting very much and going very well. Next please. Now I am talking about the buttermilk also with curd formation, mixing of the chilled water, pasteurized water, 1:2 ratio, addition of the spices and salt and then packing. This is buttermilk also now being demanded, and it's all the most of the organizations have started marketing the buttermilk. Next. So this is a first thing which is very common here. You can find the same thing is there, but we can have an addition of the sugar also and we maintain the proper acidity in the product. Next. Now these are some of the brands that Dr. Dutta talked earlier. You can see these are some of the brands that are available in the market now with the startup also and the established brands. Yes. So what I want to mention is that now there is a lot of scope in the still we are only processing 25% of the total being produced. So if you go with the value-added products, something like fermented products, which is more return to the farmers also and the sustainability of the dairy industry. Recently I have seen that Sabar Dairy has put big plant in Rohtak, which will produce about 150 tons of the curd per day, 3 lakh liters of the buttermilk, and about 10 metric tons of the yogurt. So this is one of the biggest plant in the Rohtak is coming out from the Sabar Dairy. So you can see that a lot of development. So main the challenge is to how to convert the unorganized sector into the organized sector, which is growing very fast. Also, most of the housewives, they make the curd at home. So if you can supply some starter culture for them also, that becomes useful for them also. These are some of the challenges, but basically dairy industry, particularly the fermented dairy industry, they are doing excellent and growing very fast. So there is a lot of scope for the students, for the staff, for the startup to develop these of the products and different varieties of the products, and there is a lot of scope. Next please. Thank you very much. So I would like to thank you very much for attending this. Thank you very much.
Thank you, sir. You have confirmed, such a big canvas. It's very difficult to complete within this specific 15 minutes time, but we could not complete it in 15 minutes time. Anyway, sir,
Thank you very much. Thank you.
We will take up the questions
Yeah,
later on.
something is there, certainly will be in a position to answer. Thank you very much.
Now we have another very celebrated scientist who have been working with NADB for last more than 12 years. Not a problem, sir. Winning many patents, accolades. He is the prime mover for setting up the commercial starter culture unit, and he is here in front of us, Mr. Saugata Das. So the stage is yours.
Namaskar Sabiko. Good morning and good afternoon to all. I will not take much time, sir. Within 10 minutes I will try to complete this one. I will be talking about ready-to-use culture. That is equivalent to the commercially available DPS culture or DPI culture. That does not need any propagation. We can add directly in the milk and we can incubate and it will be converted to dahi. Next slide, please. That বন্ধ হয়ে গেছে। We know that fermented milk product is one of the major milk product sector in the dairy industry. In West Bengal, without Mishti Dahi, that means dinner is not complete. Similarly, in Gujarat, without buttermilk, dinner will not be complete. So the this fermented milk is related to our culture. And for household, we are preparing dahi from previous dahi to the milk. But industrial condition, it is not practiced. They are heating the milk, they are adding culture in freeze-dried format, and they are incubating the milk, and after 4 hours or 5 hours, it is converted to the dahi. So this is called DPS, RUC, ready to use culture. It is the equivalent to DPI or DPS culture for the MNCs. But main thing is that India is the world's largest milk producer. We are producing a large quantity of milk. But our fermented milk industry heavily rely on the imported culture. So our project was conceived almost 15 years back, and we are working in this project. During the Corona period, we got many requests from the dairies that the supply chain for the starter culture is totally collapsed. So it is possible to give us culture in freeze-dried format as ready-to-use format. So after that, we plan to set up one plant. Whatever laboratory, whatever research is there, we will put in the market. We will see the quality of this one. And also, main thing is that if we try to manufacture Mishti Doi from DBS culture, commercially it is not available. Mishti Doi almost 20% sugar is there, but no commercial culture available in the market that is can tolerate on the 20% sugar. But we are having an entity, we are having a propagative format on culture that can tolerate up to 20% sugar. So our target was to convert all this type of culture, all the Indian origin culture in the DBS RUC format. Also, this project was having one objective that we will collaborate with all the people that are working in this field. We can get all the technology they have developed and we can commercialize it. Next. So whatever done in the last 15 years, I tried to summarize in this slide. So we have come out with the production process for the DBS, RUC. It is very similar, simple process, but each and each step we have standardized in our lab. Just like laboratory, we are preparing the fermentation medium, 1 liter, 2 liter. Similarly, we are preparing the fermentation medium in the fermenter. Here we are adding the ingredient, we are adding with water, then sterilizing the fermenter, and we are having a 1000 liter fermenter currently in our facility. So after fermentation, the biomass will be generated. We have to get out the biomass from the fermented broth in and we have discarded the other things. Then after concentrating the biomass, we will standardize it. Then we will go for freeze drying. After freeze drying, we get the cake of the starter culture. Then we have to grind it. Then we have to blend it. Because we know that one single strain cannot perform all the desirable activity. So we have to blend all different types of culture. Then come packaging and dispatch. Next. So I have shown the last slide, the last almost 15 years work in one slide, but it is not a simple thing. Each step having some critical things that I will highlight next by next. So first is the strain selection. The strain is important for the RUC. So what type of strain I have to select for the RUC? So we can see the basic criteria. So it is totally related to microbiology. It should have reduced lag phase, bacteriophage insensitive. There is molecular profile, also antibiotic resistance, and free from any off flavor in the milk, and bacteriocin production characteristics. Because we are dealing with dairy products, so in respect of dairy product, what is the status of the culture? This is important. So acidification and post-acidification is important. Then sugar fermentation profile. Means I have given an example of Mishti Dahi. So culture having can tolerate how much concentration of sugar. Next, control proteolysis. For cheese culture, control proteolysis and lipolysis is important because it is going to ripening also. Next is textural property. For dahi, texture is one of the important. So no whey should be coming out of the dahi. You go to North India, they prefer generally from slimy dahi. Eastern region of India, they prefer granulated dahi. No sliminess to be there. And for buttermilk or some liquid product, we have to have some slimy characteristics of the dahi. So based on this one, we have to select culture. Next is production specific. For converting on culture in the RUC format, some specific requirement is there. That is, it should be stable in the freeze drying. We have seen that many lactobacillus that is having good probiotic property, but they cannot stable in the freeze drying. So it is one of the important things to convert bacteria in the freeze drying format, means RUC format. Then each in production is high cell density, means we have developed one growth media. So whatever bacteria we are selecting, it should grow in this media. For different bacteria, we should not develop different media. It will be time consuming. So bacteria should adapt to the standardized media. And also scientific EG of concentration. Many bacteria produce huge quantity of slime. We cannot centrifuge it because of slime. And also it is difficult to concentrate by filtration. So we have to avoid this type of bacteria. Then storage stability. The protein makeup of the bacteria affect on the storage stability of bacteria, because the RUC has to be stored for -80 degrees for 1 year or 2 years, and it should be transported at the room temperature for economic purpose. So bacterial protein makeup having effect on the storage stability. Next slide. Next important point is selection formulation of growth media. In laboratory, what we do, we use MRS or M17 media for microbiological purpose. But it is not suitable for economical purpose, because if it is almost 5,000 rupees per kg is the cost, I think. So first thing is that for development any commercial media, it should be economical. Next is the veg origin. It should not contain any animal origin product. So what is the theory, but what is the principal development of a good growth media? The answer is given here. We know what bacteria does eat. The carbohydrate, protein, vitamin, antioxidant. So we have to have some concentration up and down and do some statistical analysis by RSM, and we can get one result. Two result is given there. Now it is a lab data. Lactate and biomass concentration. Based on the lactose and protein concentration, we have decreased the lactate and increased the biomass concentration. And also neutralizer. For running a fermenter, we have to add neutralizer from outside to maintain the pH. So what type of neutralizer I shall use, what is to be the concentration, so all has to be standardized. Next is the harvesting of biomass. In laboratory, we are doing fermentation. After that, in small scale, we are using centrifuge. That is called basket centrifuge, or back centrifuge. But with commercial scale, it is not possible. We have to go for continuous centrifuge or filtration, TFF, tangential flow filtration unit we have to use. At that time, I previously mentioned that some bacteria produce some quantity of slime that cannot be concentrated. So this type of bacteria should be eliminated. And that's all. Next slide. Next critical step is freeze drying. It is not related to microbiology, probably it's engineering based, food engineering per se. So for commercial viability, we have to have short freeze drying time. But how it is possible to reduce the freeze drying time? By increasing the drying temperature. But what is the shortcoming of increasing the drying temperature? Because if you increase the drying temperature, what will happen? Product will collapse. Left side you said that is collapsed here. It is not a good texture. But right side you see that it is good texture. So if bacteria is collapsed, if the matrix is collapsed, so it will not give any output. So you have to switch to right side. But how it is possible? Because we have to decrease the freeze drying time, but similar time we have to keep the viability intact. So we can see in the graph, in the normal condition, 760 mm, this is the atmospheric pressure. So ice, water and vapor. But if we go downwards, then directly ice to water, vapor, based on the pressure. So this area, this red color area we are working. And this red color area can be elaborated that side. Suppose the pressure, this is milliliter pressure. Milliliter pressure is suppose 476 milliliter pressure, the respective temperature is -25. So from this table we have to select the temperature for drying purpose. So based on this science and the quality control, we can achieve the short duration time. And I can say that in laboratory scale we are having a small freeze dryer having shelf area 0.33 meters square. And we have now commercial freeze dryer almost 15 meters square. 0.33 meters square to 15 meters square we have done. But no batch failure, nothing is there. We straightforward done the upskilling. Next. Freeze drying, another thing is that freeze drying running good, no problem. But bacterial survivability has to be more. So we have to add some protective element to keep the bacteria intact. What are these? These are categorized in this type of polymer, carbonic, dryness buffer, antioxidant buffer and salt. So based, we have to select appropriate chemical composition based on the, because first Streptococcus thermophilus one type of component will be there, Lactobacillus pelagicus one type of component is there, different strain, different component there. So based on the bacteria we have to select component, we have to adjust the percentage of the concentration and we have to RSM and we can come to a conclusion that what is the optimum concentration for this particular bacteria. Next is that I told that our RUC should have shelf life of 2 years with a 10 days transportation at room temperature. So for this one we have to keep the product stabilized for almost 2 years. How can we do it? This is another question. So if we go to science, then again we will find one graph. Every powder having two states, just like SMP. SMP having two states, one is glassy state, one is the rubbery state. If we take one simple eraser for our pencil eraser, it will be very soft. But if we keep inside the fridge, it will be very hard, brittle. So one temperature is there that converting to rubber into glass. In the glass state, the molecular movement is very less. So chemical reaction will be very less. In the rubber state, movement of molecule will be very high. So it will degrade very easily. So based on addition of some compound, this is called glass transition modifier, we can make the product stabilized for a long time. And we have achieved 2 years stabilization time, shelf life. Next slide please. Next thing is that पानी नहीं है. Next important thing is the customer satisfaction. If you go not Gujarat, they will ask for high sour dahi. If you go to Anand, our nearby area, they will ask for less sour dahi. I told that North India they will be asking for more EPS for slimy dahi, and eastern part they will not ask for, they will ask for granular dahi. So based on acidification, texture and flavor. Flavor means some ask for the creamy buttery flavor. So 3 target is there: acidification, taste and flavor. We have to target the 3 things. Then we can satisfy the customer. Different customer having different requirement, and we have to achieve this one. Next slide. But question is that we are having different strain with us, bacterial strain in RUC format, and we have to serve different customers with this strain. How it is possible? One example I have given there. Here you can see the 3 bacterial strain is there. ST16, ST4.4, STD. This STD is fast acidifier. It can form dahi in 4 hours. Other 2 strain will take almost overnight time to convert milk into dahi. So by combination of this starter, we can achieve our target. You can see that your statistical design I have put here. Here total will be 1. So ratio I have maintained to maintain the costing also. So different ratio I have added this culture, and you can see that this is the input, this is the output. The 4.7 pH achievement is done in less time when D culture concentration is more. It's red color, you can see there. If D culture concentration is more, then it will take less time to reach the peak 4.7. Similarly, if you got the hardness is variable. Depending on the color of the graph, we can come to the required concentration ratio of the culture. So I want to say that by variation of the culture combination, we can achieve fast culture, slow culture, then high hardness product, less hardness product. Okay, and this is the same. This 9 combination is there. You see in the sensory, it is a principal component analysis. This 9 position is different area. So by changing the combination from the same strain, we can achieve satisfy different customer. Next slide, please. This is our product. We have already launched the product in the market, and this is our total catalog of product. So based on the acidification, we have fast, medium, slow. For creaminess, low, medium, high. Flavor, mild and diacetyl. When we are telling the diacetyl is there, then it means mesophilic, leuconostoc, lactis, diacetyl lactis, this type of culture we are adding in the mixture. Now question is there, someone will be asking that why slow culture? Suppose a 5 liter pack, we have given for fermentation. After fermentation, we keep in the glass freezer or freezer. So immediately it will not get cool. It will take some time to get cool, almost 2 hours, 1.5 hours. In this time, if we give fast culture, so the pH will go down. So it will not be accepted by the customer. So what is that? This type of culture, slow culture, it will bring the pH almost 5 within 3.5 to 4 hours. After that 5 pH, it will take long time to go to the 4.7 pH. So by engineering all these things, means combination of different culture, we can satisfy different type of customer. Next slide, please. Our plant already inaugurated 6 July, and by our Home Minister or Cooperative Minister, Amit Shahji. This picture is there, also news is there, and this is our final packet. All the marking is there, and we can say that this is the beginning. We are facing customer having more expectation. So as per customer, we are developing ourselves, and we are happy to say that we have captured all the NDDB controlled dairy unit. They are using our culture, and we are expecting now winter is going on. When the winter will be going on and summer will be coming, our volume will be increasing. Next. Our team is small, we are increasing gradually. Dr. Singh is leading our team. I am second position. And these 3 new scientists have joined our laboratory. Inside, Praksha madam is virologist. He is working on virus. Amit bhai is working on probiotics. And Monica madam is working mainly. He is taking care of the molecular biology activity. That's all. Thank you.
Thank you so much. We'll take the question later. You see, we have tested this product in our commercial, and we are not yet totally happy. But then the next sample will be coming. Ladies and gentlemen, time is a constraint, and now we have another very, very eminent scientist with us as the next lecturer. She is the lead scientist at IKC Life Science and Technology Center. She will bring in long years of research and development experience in ITC, in NDI, in PGINR. So let us hear her. Madam, stage is yours.
Thank you, organizers. Thank you, forum. From last 2 years, last 2 days, I was actually delighted to hear all the scientific presentations in the field that I am actually working on from last 20 years, I would say. I am a clinical biochemist who was introduced to the world of microbes in 2006 when I joined MDRI, and I started working on the project on probiotics. And since then, I think the fate has taken me in this direction this long. I have never left reading about probiotics in the last 20 years. So, and the things have evolved so much. I would say that from the time when I was told I have to work on the area of probiotics, the first question was, how is this small tiny organism is going to do changes to my system? And what I was intrigued to find towards the end, and what we are actually exploring right now also, is these microbes are not alone. The way they work is in a synergy as a complete army that actually change your system. And probably I'm not going to share a lot of science because we have heard it in the last 2 days. I'm going to share a perspective that I actually feel should be brought in front of the scientific community to think about one area that probably we can leverage for the, I think I have written it as global, but I think for India also we actually have to see how we can leverage this particular perspective to see how we can drive health and wellness through microbes. So going to my first slide, if you just please. This is something I probably want to bring it onto the table is, when we are talking about fermentation, we always talk about fermentation of food, right? One thing that I am actually more delighted is all the foods are getting fermented. There is no food that does not get fermented because once you consume it, your gut bacteria is anyways going to ferment it. So even if it is a non-fermented food, it is going to be fermented, it is going to do something positive and negative for you. And this is something I was very delighted to hear about the One Health concept yesterday, and today also it was revised, because we are in this soil and everything, even if it is in food or it is inside us, we are all associated. You cannot separate us, and that is probably I want to show in this particular diagram where it is well proven that why Japanese can only digest sushi so well, because they have evolved microbes from the fish which is able to digest the fish meat, right? And how our salivary inoculums and hand inoculums have been given to cheese and the specific type of chicha wine that is there in the American society. So basically what I want to say here is that human is a holobiont. We are not existing in silos. You cannot say that food is fermented and then what happens to the body. We also have to consider how this fermentation that is happening is going to impact me as an individual. And how it is going to impact me is not only because of the microbes, I would say. It happens because what it actually does. And if you go to the next slide, please. Before I go into the host, the metabolism, what the food does, etc., a very beautiful study I've come across, that's a very recent publication, and what they have been talking about is, people actually tried to sequence the genome microbes that are present in the foods. And to my surprise, not many Indian foods are included in this particular sequencing or the consortium that has been done. So only a few Indian foods, I think 2 of them that are soybean based, and most of the European dishes are included in this particular scanning, where they have identified 2,000, they have actually sequenced 2,000 genome, and what they have found is they have more than 10,000 microbes that have been sequenced that are present in fermented foods. Now what is it opening for me? I mean, as an individual, it's opening for me a canvas that 10,000 plus organisms for 2,000 plus species are ready to be used because they have a history of consumption. People have been consuming it. We are talking about a few probiotics, prebiotics. There are 2,000 plus species that are sitting there and they have bioactivity. Nobody has scanned it so far. Can I do that? So that is one question probably I wanted to share with the forum is, we have a lot of things that are sitting with us. And how do we leverage it for host health is something that is up to us. You go to the next slide, please. Now comes to the area that I'm more interested in is how does it impact health, right? And most of the pathways, how bacteria, different type of microbes that impact health have been well established. There are species that have specific effects. There are species that produce short-chain fatty acids that helps in immunity, nutrient absorption, etc. There are species that are involved in production of some metabolites like GABA, etc. that impacts your behavior. So those things are well established, has been proven from 2010. It's not a new news. But what is new is how do they work together, right? They are not working in silos. All things are happening together as a consortium. The body is actually responding to what goes in. And how do we leverage it? How do we leverage it? Well proven that people who consume fermented fruit have a higher level of CLAs in their body. Bacteria have a good ability to produce vitamin B. We have been giving vitamin B as supplements, bacteria have the ability. How do we improve that, right? So that is another thing. So intriguing, right? Give food that can improve your health, right? Is it that simple? If you go to my next slide, it is not that simple, right? There's a very good study that is done in Europe and US together, the PREDICT study that proved that same type of food given to different people can have different impacts because they are impacting the fermentation differently in different body systems. So when we are designing foods, we are designing it for specific health, we are designing it for health, metabolic health, brain health, etc. Are we also considering what is going to happen in the body when this particular food is getting delivered, right? So this is something as an area that I think we should all be pushing for, because when we have seen a lot of publications and studies that are done for fibers, probiotics and prebiotics, they are non-responders. A lot of non-responders in these studies. And why are they non-responders? Is because their body is not equipped to process those fibers and probiotics that are given, right? So when these non-responders get a gut-targeted therapy or an intervention to change this metabolism, they will become responders, right? So to convert non-responders to responders, you really have to work on the gut, and that is where I actually want to leave a thought. If you just go to the next. So now this is a very small thing, right? Health is not very big thing. I probably have attempted, I won't say I have attempted to find one piece of the unsolved puzzle so far. We talk about microbes, we talk about health. One puzzle that was lagged was how actually these microbes impact health is through the metabolism, how our type of fermentation, in situ fermentation that we call, unfolds in the gut, right? Why it is a big deal, if you go to my next slide, is because what we are attempting for is a big question. We are trying to attempt to solve a big problem, sustainability problem of health that includes overnutrition and undernutrition together, diving on food. And food, my full confidence is that if we work on food properly, we would be able to dive it through, because there are a lot of established evidences, even in Bangladesh itself, that when the children were fed gut-optimized formula, they were able to combat malnutrition. Not only with the high energy dense meats, you have to work towards the gut to achieve it. And my gut feel is, if we really want to deliver a sustained nutritional impact without working on the gut metabolic pathways about how it unfolds in the gut, what happens, what type of metabolites are being produced, am I optimizing amino acid utilization, am I optimizing the nutrients utilization, am I optimizing the barrier integrity function, that is equally important to establish. So if you go just next, how do we do it? The question is, we have a lot of ancient knowledge. There are a lot of ancient microbes that were present in ancient microbiota. My slide actually depicts that. There was a study that was done in Tanzania where they have done the metagenomic sequencing of people from Tanzania, Malawi, which are mostly farm-led communities, and USA. They said that the microbes have lost their functions, microbial functions, the redundancy, metabolic redundancy has lost. What does it contribute to is we are not able to process the food in the same way as we used to. How do we achieve it? The diets in the ancient times were devised in a way that they feed different metabolic pathways. They were not so simple. Refined sugar, refined carbs, mix it together and eat, right? They had a complex, complicated diets that basically lead to the diversity of the consortium, and that is basically where the whole thing lies in, and that is how we should dive in for. Just go next. Just few examples I've just tried to put together is how people have actually started leveraging the whole thought process. Just go next. I won't take a lot of time. We have been talking about probiotics, prebiotics. It's a good part of the story. We have started establishing, working towards it. But what can be done more is how do we optimize it for the specific areas of work. So there are some examples from some startups I've taken here, where metabolic pathways have been reprogrammed. So this is probiotics, prebiotics, well-established products that are there in market. But there are projects now that are coming into the play where startups are playing a role. So this is a US-based startup called Pendulum Nutrition, basically which has devised a probiotic that has an ability to control the glucose homeostasis by working on short-chain fatty acid pathway and bile acids. This is a very interesting startup probably, and this is, I have read about it very recently. Its name is Converto. Basically, it converts. So what they are talking about is the sugar that you take in during the digestion process, it will be converted into inulin. So what is available to your gut at the end of the whole metabolic pathway is only 30% of the sugar will be converted to inulin, and that 70% is only available for your body to take in and go into the metabolic pathway. Just go next. Three more interesting examples. So this Z-Biotics is another probiotic organism which has been transformed for acetaldehyde dehydrogenase activity. What it does is acetaldehyde accumulation in the body basically is toxic. Mostly it causes hangover and other side effects of alcohol. So they have developed a Z-Biotic product, a probiotic, which has an ability to degrade acetaldehyde to acetate, so it becomes non-toxic. So anti-hangover, probably the effect that they are talking about. For the sports nutrition, it is specifically lactic acid that accumulates in your body as well as in your gut, and that created cramps in the sports person. Nella has actually nailed it, and they have identified the pathway to neutralize lactic acid, and then it can be directed to production of acetate, and you will not have side effects with respect to that. And this is another very interesting thing, and Simcon is one of the attempts to use a consortium. I've been talking about consortium of different metabolic activities that happen together. Simcon is one of the attempts, it's till the in vivo experiments only, where they have actually attempted to use bile acid, cholesterol and cholesterol metabolism to direct body towards less cholesterol accumulation, throwing it out to the stool. And they have proven it in animal models that the consortium that has been metabolically targeted was able to establish lower cholesterol absorption. So just wanted to summarize my story saying that next-gen products are being designed to optimize metabolic behaviors. And just go next. The question that I just leave to the bigger scientific forum is that when sustainable metabolic impacts upon on microbial governance, why are we still designing nutritional products without considering it? Thank you so much.
Thank you, madam. See, time is the real restrainer here. Thank you for integrating our 40 trillion cells with 400 trillion microorganisms here. Thank you very much. I will request Dr. Parekh, Mr. Sogata to come on the dais because we will take one question each. We are running out of time. We will take one question. Please come here. And I will request Dr. Subrata Hati to come instead of Professor Shobhit. Please come on to the dais, sir. And if there is any question, please prepare your question. We will take one question. In the meantime, we have something to do. Please do that. As a matter of fact, our next session starts from 2:30, and now it is more than 2. I don't think we will be able to start at 2:30, but 2:45 could be here. So in the meantime, we have something to do. Please do that, and prepare your question. We will take one question each.
May I now request your kind attention for the next segment of the session, the presentation of the tokens of gratitude. At the outset, on behalf of the organizing committee of this conference, I take this opportunity to express our sincere appreciation to our respected chairman of this session, Dr. Ashita Boshu sir, and rapporteur, Dr. Kumaresh Haldar, whose gratitude, insights and scholarly moderation have enriched this session. May I now request the Honorable Vice Chancellor, Professor T.K. Dotto, to kindly honor Dr. Ashita Boshu, the chairman of this session, with a token of gratitude.
I am an encroacher in your session.
Sir, again I would like to request you to honor our rapporteur, Dr. Kumaresh Haldar. Thank you so much, sir. Our sincere thanks are also due to our esteemed invited speakers, whose valuable contribution have added depth and perspective to today's discussion, may I now request our chairman of the session, Dr. Ashita Bosur sir, to kindly present the tokens of gratitude to our invited speakers. Second up. Dr. Shomit Dotto is not here. On behalf of Shomit Dotto, I would like to request Dr. Hathi to take this honor. This is the time to respect our respected J.V. Parekh sir. I would like to request sir to honor him. This is the time to honor Mr. Shaukato Das. I would like to request sir to honor our ma'am, Dipti ma'am, Dr. Dipti Kaushal, with this honor. Thank you so much. This is the end of the session.
No, before that, do you have any questions of the audience? Yes, please. I can hear you. I think we can hear you.
Yes.
Speak up.
Sir, do you use the same culture for Mishti Dahi or Mishti Dahi for mango dahi and all, for flavored dahi?
Not really, but who would answer this?
For flavored dahi.
We are having one Mishti. We are having Mishti Dahi culture in our bank. It is under pipeline in the form of still to be converted into RUC. It is under pipeline.
The same culture is not used for.
Can we use the same culture for Mishti Dahi, sour dahi, mango?
Flavored dahi.
Mishti Dahi required sugar. This culture required sugar. If sugar is in the milk, then it can be used. If not there, it cannot be used.
So flavoring agent doesn't affect the culture?
No.
We need the culture which will tolerate higher sugar.
Yes.
That is why it is bit different than the normal.
So that will be a different culture. Thank you very much for your question and the answer as well. Any other question? Ladies and gentlemen.
Sir,
yes, you have a question, please.
Yeah, ma'am, very nice. I have a question for Deepti madam. Ma'am, very nice presentation. Really the point you have highlighted that we have to look into the metabolic curing part. So actually we did some community survey. People in West Bengal, in the Midnapur region, they consume this panta bhat, and our VC has also put some highlight on that one. So what we are finding is 80-year-old woman, she is able to consume that panta bhat, but younger generation, they are not able to take it. So from the physiological aspect, what you are working on, can you please highlight how we can do something that this kind of product can be taken by all the people?
See, so when I am talking about specifically how do we tweak metabolic pathways of fermentation, what the ancestors or probably the ancient people have been tuned into, their consortium and the diversity is higher than what we are having it right now, because the type of food that we have been consuming is one type of food, this specific type of food that we will be consuming. We are not consuming even seasonal things. So the diversity that I am talking about is completely lost. What it is doing is, when we are bombarding our body with a certain spike of sugars, it is producing a lot of short-chain fatty acids that basically leads to gas and bloating, right? So what when I'm saying people are not able to consume things which are fermented or healthy, they basically complain of gas and bloating that they feel. The reason is, one, you do not have the diversity to digest it. Number two, it is being suddenly bombarded. Now the two things that have to be done that I can suggest is, one is you tweak the particle size so that the fermentation becomes a little slower. So you're not bombarding your system with a lot of easily accessible carbs. It is slow digestion of those fibers that leads to lesser bloating and less gas formation, so you don't feel discomfort in the due course of time. So that is one thing. And second thing is, you also have to see what are you giving to promote the positives versus negatives, and that's the second part of the story. I hope I have answered your question.
Thank you.
Yeah.
Yes, sir.
I don't have a question, but it's different angle to this answer.
Actually, the person who referred to that, they can digest more of Pandabat and then be like this. So there are so many people in this country who have very excellent gut microbiome. We met a 103-year-old farmer in Goa, and if you see, he's so physically fit. So there is a now this concept of fecal microbiota transplant. Those healthy individuals who have very good diversity of microbiota and very good digestive system, that fecal transplantation can be done into other people looking to their physiology and so. So this is a good concept going on, and Reliance Institute in Geo, Mumbai, has now bank of fecal microbiota, and Artemis Hospital in Gurgaon also is doing now. So if you have anybody who is more than 90 years or 100 years and in good health, this kind of microflora are preserved in a bank, and this can be given to the patients for curing this kind of metabolic problems. Thank you.
So, Madam Deepti, what is the take-home message? Any take-home message?
Yes.
We should diversify our food.
So,
Less of packaged food. I mean, these are very big terms.
So basically, I would not say we can restrict things that are convenience, because that is the part of our life. We have to go with that. But the take-home message is we have to be mindful while we are eating and making choices.
Yeah, that's a political answer.
Political answer in terms of so I'm just closing it with the thing. It's mindful in terms of when I'm saying mindful. When we used to say 7 colors for a week, right? There was a reason. Polyphenols are present in those colored food and vegetables that basically leads to the propagation of good microbia, right? We were talking about echinacea yesterday, right? That is related to glucose homeostasis. That is present. That is regulated by the presence of polyphenols, right? So color. When I'm saying mindful, you be cognizant about the colors. You be cognizant of balance. Balance. When I'm saying is very generic terms. We have been talking about proteins at this point in time, right? But we are not talking about protein to fiber ratio, balancing protein with carbs. A lot of studies have shown that protein without balanced carbohydrates are going to give you long-term health effects. And there have been studies that have been published. If protein is not balanced with carb or the fiber that I'm saying, so it will lead to long-term chronic issues like cardiovascular health issues. So those balancing is something I think we should do. Seasonal has to be propagated, fermentation has to be propagated as a mean of optimizing nutrition, because gut-directed diets are the future. You have to really optimize it for gut, because otherwise there are studies that have been proving only supplementation is not going to work. You have to work to optimize the environment to take it up. So that is, I think, that is the future. So think about how it is going to impact it. Yeah. Thank you.
Thank you very much. It is not the chairman, but the time is cutting this engrossing discussion of the interaction right now, because we were supposed to start our next session at 2:30 and we will be starting at 2:45. I said that we will complete by 2. So 2 is over. Thank you all. Thank you very much. And we